my practice and my work. And I'd like to thank Professor Navarro and Professor Ajuse for the invitation to lecture here. And it's really wonderful to get to know your school and our school being in such close proximity. I am one of the undergraduate program chairs here at SciArc, along with Christy Vallier. We collaborate in that position, and a lot of my work really emphasizes collaboration. So our practice, Servo Los Angeles, is comprised of 2 partners here in Los Angeles and 1 in Stockholm. She is running Servo Stockholm, and we work together. And so to me, it's always been important, the idea of collaborative practices. And as Gilbert mentioned, our work is very interested in the distinctions between what we would call exact things and things that are maybe less able to be measured, less exact. And so I wanted to begin with some of the inspirations. This one coming from Marcel Duchamp, who was an artist. This is a very old piece from 1914, where Marcel Duchamp was actually commenting on the sort of ways in which we create systems of measurement. And it's called 3 standard stoppages. And he took pieces of string and dropped them from a height of 1 meter onto a floor. And then he made a notation, the drawing on the left, of like the form that those threads took as they landed on the floor. And then on the right, you can see he made a system of rulers, thinking about, thinking about how the meter as a system of measurement is maybe, it could be arbitrary in a sense. Like, how is it that we define the things we use to measure? And so I've always loved this piece because it really reflects on both the precision of drawing and the ideas behind sketching, but also their translation into a physical object. This is another work by an artist from Los Angeles, Ed Ruscha, who did a whole series of paintings of words, but using the technique of painting to make the words appear as if they're made of different materials. In this case, it's supposed to look like honey, like something that's fluid, but it's very carefully delineated to produce that effect. This is another artist that we are very inspired by, Roxy Payne, who makes these paint sculptures. And I think what's fascinating here is that the formal qualities of the sculpture are determined by the material itself. So this idea of material having some role in the making of form, rather than form always being imposed from an abstraction, but looking, how does material behave when we work with it in different ways? And so that, I would say, is one side of the coin. This is another inspiration. One of the people I was taught by, Greg Lynn, who's a professor at UCLA and also teaches in Vienna. Greg Lynn had developed these drawings as a way of showing, when we're working with forms that are maybe different from the logics of a kind of orthogonal right angle system, how can we begin to rationalize them and create a set of precise lineaments that would allow us to think about how we could construct some of these forms? So the idea of taking a curvilinear form and making it into something that is faceted, that might be able to be constructed with panels. And Linda Benglis, another artist who really challenged the idea of the tools behind painting. She is, I think, very inspirational in that she said, rather than painting something with a paintbrush, she would actually pour layers of paint into different spaces and allow the paint to dry and take the form, creating a kind of irregular edge and exposing all the different layers of color in that space. And this is one of our drawings. It's a contour drawing of an elevation of a building that is showing also, I like to show it with the Linda Benglis, because it's almost as if one could then begin to create a drawing of that space. It's also like a contour drawing, the way we contour a landscape, and we show that maybe in a site plan. this is actually looking what would happen if we started to think about elevations of building having those kind of landscape qualities. And then some architectural inspirations, looking at the role of digital technology. That's something that when I did my doctoral dissertation, I was writing about how architects were thinking primarily in the 1960s when computers were just kind of emerging in the popular imagination and becoming more available. How would architects translate that into their work? And so this is by a Japanese architect, Kisho Kurokawa, who designed a floating city based on this logic of computers. And it's kind of funny because it actually looks like the circuitry inside of, like, if you would open up the computer. And that was sort of the design, the logics of thinking about circulation networks in an urban space in this floating city. And then this is a building that I very much focused my doctoral dissertation on, that was designed by a collaborative group. Again, the importance of collaboration. There were some engineers from Bell Laboratories who worked together with architects and artists. And the architect Tadashi Doi, who was a Japanese architect. And then also some artists were involved in this collaboration. Robert Breer and Fujiko Nakaya, who is a woman who designed this kind of artificial cloud. You can see the cloud around the building. The one on the right side is the actual environmental cloud, and the one on the left side that begins to obscure the building was designed by the group, the collaborating group, as a way of saying, how could architecture produce qualities that are both like hard qualities, that we can see the form of the roof, the panelization system, but also soft qualities, the presence of this vapor. Then, excuse me, this was an expo pavilion, so it was meant to demonstrate the technology of the time. It was done in 1970 in Osaka. And this image shows children playing with the small robots that the group designed, like very gently. If you push them, they would start to move across this plaza. And for me, that was very inspiring, because really thinking, how can architecture start to become responsive to human presence and to other kind of agencies in the environment? So this is one of our early works from Servo Los Angeles. This is a project that we exhibited in Graz in Austria. We were invited to participate in an exhibition, and they asked for designs that would start to kind of create a spatial subdivision in the space, not really building a wall, but something that would allow you to sort of see through and would change the light levels in the space. And so we became interested in how the sort of plastic pieces that we were working with, that are these cellular modules, would be used to construct this wall screen system. But then in addition to that, we had the idea of modularity, that in order to make things quite efficient, that from a set of pieces that are identical, you could plug them in different ways to get a different arrangement in the piece. And so you can see this here without the lighting. And then this is a plan looking at how the cellular system would be suspended from the ceiling. And as you walk through, a set of motion sensors that were installed in the ceiling would begin to trigger relationships between the lighting fixtures in the cells. So as you move, your body would actually, these are diagrams that we created. This is our partner, our collaborating partners in Stockholm at the Interactive Institute. They were engineers who worked with us, and it was really a wonderful exchange between us as the architectural designers and they as the engineering designers, and sort of how do we begin to create something together. This is the piece when it was finally installed. And these are some images. You can see blurry figures as people would move through. The light would kind of track their movements. And so we talked about this as kind of creating light drawings in a space. And then a later project, we also wanted to work with this idea of responsive environments and interactive technology. So we were invited to exhibit at the Schindler House in West Hollywood, the Mack Center for Art and Architecture, which I would highly recommend taking a trip out there to see this house. It's a beautiful work of architecture, and some of you may have studied it in your classes. The main feature, I think, of this house is really the way it embraces the connection between interior space and exterior space. And so there was a group exhibition, and they were assigning different parts of the house to each of the exhibitors. So we were given the nursery, which is the small space that you see here. And then we thought, wouldn't it be wonderful to create a piece that would emit like sounds and could almost thinking about the lullabies that one might sing to a child in a nursery. So again, we worked with this modular system that attached, because the house is very historically protected, we had to just use suction to attach these pieces to either side of the glass. And you can see here the section showing that and some of the diagrams. And that, again, that system could be reconfigured in many different ways. Within each of the modules, we had a small computer microcontroller chip and a light sensor and then a speaker. And so as the light would hit the house, as the sun was kind of moving, or as we were moving relative to the sun, the lighting conditions would change, and this would trigger sounds to be emitted. So these are some of the diagrams about the connection between those sensors. And so again, this is sort of the hardware of the piece, but we were very interested then in the presence of these kind of clouds of sound as it moved through the space. The other thing we were thinking was, this is in some way is reflecting the idea of how the house is kind of bringing the exterior into itself. And so we thought of this almost as this kind of vine system that is kind of like moving, is growing into the house and from the exterior to the interior. And so we took on the context of the very lush gardens that are next to the house and started to think, how could this piece really respond to that context? And then this is a later project that we did for a environmental research center in Stockholm. Again, an unbuilt project that's a speculative project, but we were very interested in learning about how a roof could become an intensive green roof, one that has some depth and one that has some undulations, and how that could create different microclimates within the space. So the idea was that in the diagram, we show the different biotopes of meadows, dry meadows, open mire in the region on the right-hand side. And then we started to look at that as like a small version of that could exist on this green roof. And we collaborated with a green roof designer who was giving us advice onto how this whole system could work. And so the idea was that you wouldn't have like a separate roof and then walls, but rather the undulations of the roof would allow the subdivisions of the spaces to be made, and that inside you would begin to see glimpses of the roof. Excuse me, I have a little bit of a cough still. This is a diagram of the small nozzles that would be installed to irrigate the roof. So we really were thinking of the roof as the major constituent of this space. And you can see some of the sections, how the roof folds down and tucks under. There are two pieces that start to work together to create different shaded areas. This is a model of the proposal, a 3D printed model of that. And some more diagrams. Look, and we were kind of interested as well in water catchment and how the water would begin to collect. So some of those areas that are more marsh-like would begin to thrive in the lower points of the roof, whereas the higher points would shed the water. And these are some of the diagrams showing the specification for which plant communities and which plant species would be growing in these different parts of the roof. So these are just images of imagining how the qualities of that could change over time, and how from the interior one could begin to really reflect, we're used to having maybe buildings, windows on the exterior of the building, but in this case, the window is kind of inside the building. I'm just seeing, I think there's something in the chat. If anyone has questions, please ask. Oh, I thought I saw it. Okay. And please ask you can also raise your hand and speak if you have questions. But at the end, I'll open up for questions as well. So, oops, this next project is, as Gilbert said in the introduction, we're interested in also the history of architecture and where some of the forms are coming from historically. So both looking back and looking ahead at the same time. And in this project, we started to look at the fluting on a classical column and the way that the geometry, circular geometry, when it begins to intersect, starts to produce, excuse me, starts to produce a cusp, like a change point. This is also another project that inspired us by the group Super Studio, a group of architects from Italy who in the 1960s designed this lamp. It was called the Passion Flower lamp, but it was very interesting how one surface could start to be subdivided and produce these different kind of spatial qualities. And that inspiration was behind this project, which we designed. This was built in Stockholm in the interior of the Bonniers Art Museum. It's called the Bonniers Kunsthal. And they were hosting an exhibition of sound artists. And the exhibition was called More Than Sound. And we were invited to create a kind of series of small installations that would allow people to, they would start to separate the space, but also create like a continuity. So people would move from one area of the exhibition to another. They really requested that we keep it very mute, that instead of having, we wanted to introduce some color, but they wanted to really focus on the sound. So the architecture shouldn't really compete with the sound, but just be a gentle presence. So this is one of the walls that we designed. And you can see here in the plan, these small walls start to make a kind of continuity between various spaces in the exhibition. And I'll just show the wall. They were built with stud construction, steel stud construction and drywall. This is, excuse me, one that I think is really very much looks like the pages of a book that are turning. And we were trying to create this idea of the space being very dynamic, even though these pieces are not actually moving, the way that the changing light qualities are reflected off the surface. Actually, throughout the day, when we stayed there, we noticed that they changed very much as the light is as it's getting darker or lighter in the space. Also, we were interested in their dialogue with some of the other existing structural systems in the building. So the columns, the vertical circulation of staircases, the mullion system on the curtain wall, all of those things sort of starting to begin to engage and dialogue with these new insertions into the museum. And so it was really wonderful to actually begin to move through the space and see how they create like layers in the building that before was just one very large open space. And this is the reading area. We were trying to create also a reference to like turning pages of a book and thinking about how the program of the reading area in the museum could be reflected. And then we took this idea of the cusp and we started to look on a different scale, thinking again, we had another opportunity to propose a multi-purpose space for the school. This is when I was teaching in Stockholm. And so many of the projects are at that time were being produced. I was teaching at the Royal Institute of Technology in Stockholm. And so we started to produce these small models using CNC milling through some of the wood and then 3D printing pieces. And we were very inspired by Jules Mansart, this building in Arles in France, and looking to classical forms of stereotomy, like how stone would be cut and how a groin vault, in this case, there are several vaults that are intersecting, and it's such a beautiful roof. I have not had the opportunity to go here in person, but I would love to someday go into this space. And when you see in more close up, it's just fascinating how the grain of the stones, these stonemasons were it's so very carefully constructing each component. And so it's a very specific tectonic relationship for how those cusps work and how the lines become present and the grain of the structural system itself. So these are some more studies looking at how the CNC tool, the routing tool, could produce different qualities, like plunging the router into the form of this proposed roof and seeing how we could create a series of grooves that might also hold mosses and lichen and plants. Also in terms of material qualities, we were torching wood, as it's a traditional Japanese practice as well, to generate this kind of charred wood that also seals the wood from water decay. And then we were looking at the tool path, like what is the geometric tool path that is being produced in order to CNC these pieces, and how that also kind of generates a drawing. It's a drawing that's really intended for the machine, for the code that is going to drive the router. But also when we look at it architecturally, it starts to become a drawing of some of these surfaces that we imagine for the roof. So this is a physical model showing a kind of skylight and how, again, the roof was really undulating and working with cusps. The idea here, the underside of this model, we very much like to work with physical models. And then these are some of the drawings of the roof plan and its contours, and then the space inside, which was as a multi-purpose area. It should accommodate a small auditorium and a small office area. There was a stair. And again, the biotic roofscape, we were looking at how we could specify different forms of very small scale vegetation, but that would start to thrive on this roof and really become a living roof in the project. And these are just some of the renderings that we produced. This was on the Royal Institute of Technology campus. So a student center where you could have lectures, you could have musical performances, different forms of gathering could occur in that space. And so you see it in the context of the campus. And the next project that I will show was inspired again by looking into the history of architecture and looking at different forms of rustication, like how is stone used to create different qualities on a facade? How does the elevation change? And in some of the classical work with rustication, the bottom of the building was the most very like roughly large scale rustication, because it was sort of where the building meets the ground. It was kind of a transition between the space of the street and the elevation and the architectural interior behind. And then often, as in the diagram at the right, you see often at the top level, it became more smooth and polished. And so we started to think about how, and I love this slide, I always love, it's called vermiculate rustication, because it resembles like worms, and how the stone would be treated to become much more dynamic. Like when we think of stone, we might think of solid rock. In this case, it's really being treated in a way that allows us to think of it more like a textile, in fact. And this was a proposal for a mixed-use residential building in Katrineholm in Sweden on a small town square. And we were again thinking of these qualities of rustication. And this was one of the first slides when I was showing the contour drawing came from this project, where we started to consider, could we have rougher forms and sometimes smoother forms, where there are like pockets within the facade or where there is texture, and how that could also hold vegetation, and different forms of vegetation could grow on that. So these are some of the contour drawings of what that surface would look like. And then just seeing the section relative to the exterior, and starting to look at how sort of more square punched windows would be sort of interrupting that kind of pattern of rustication. And then, you know, the challenges of the organization of because the housing units, there's a degree of repetition, and then how the formal logics could also set up some difference in the context of the units that repeat. And these are more of the close-up drawings. And then this project was this is a drawing that's installed on a wall. This was in the SciArt Gallery here where I am today. This was back in 2013. We did an exhibition, and we were interested in taking the idea of these kind of roof tiles from the earlier project, that the green roof project that we designed for Stockholm. And the idea there was, we had the undulating roof. In this case, we were working with ceramics and trying to develop big tiles that are three-dimensional, the things that are sitting on the floor of the gallery, and looking at the relationship between those and a series of lighting fixtures that we designed, all using the same geometry. This is the kind of geometry behind it. It's quite simple. We used spherical forms and some conical forms and began to intersect them. And we produced these series of tiles that are meant to hold water and channel water. The ceramic is formed as it's a slip casting. So you make a negative mold and you pour into it. In this case, we used like a composite with grout, and we fired some of these as ceramics. The challenge is the ceramics shrink. I just wanted to show some of the process because I really love the process of casting and mold making. So first we took our geometry from Rhino, and then we exported that to a file for the CNC and milled that out of foam blocks. And then there you can see the foam, and then that gets covered with a silicone to make the molds. And then you can begin to paint in the layers of either your ceramic slip for slip casting, or in this case, this was one that we did with a grout mixture. This is the negative jacket of the mold. That's removing the mold. So it's just a whole process. And we were very interested in these kind of imperfections that occur, because much like the project for the building where we were looking at rustication, this is very small scale. We wanted to use different admixtures to get different qualities on the surface so that you could have porosity and water could collect inside of the tiles and these small plants could grow. So these are very many views of that. And then we, for the exhibition, we said, well, we're not going to exhibit this as a roof in the gallery, but we're going to create almost like a garden of these sort of seating elements, and then the lighting elements that are suspended from above. And so we collaborated with a glass blower. We took our molds to a professional glass blower who worked with us to say, how could we make these out of glass? So again, the same geometry is driving all the pieces in the exhibition, but with very different outcomes. And we were very interested in the glass blowing process because depending on the temperature and the amount of pressure when you're blowing the glass, you can have it expand in different ways. So each of the lighting elements is unique. This is a picture we went to the studio. It's quite a medieval process, really. It's very ancient. And we were assisting the glassblower by holding the two-part mold together, and then he was blowing into it, and then he would tap his feet and we would pull the mold open, and then he would bring it to the kiln. It was really like a really amazing process that we learned from this glassblower. And these are some more of the shots of this in the exhibition. We also wanted to work with the idea of the cabling system rather than concealing the cables. The SciArc students, when you have an exhibition in the SciArc gallery, students get academic credit if they want to volunteer to be on the exhibition team. And so we asked the SciArc students in the workshop to design the cabling system as a kind of presence in the space. And so to make it very drippy and stringy, and they came up with several different ideas about that. And this, showing a lot of slides here. This is a drawing also installed in the space. These are some of the details for how they started to like loop the cables and knot the cables. And it was really, it looks quite light, but actually it gets quite heavy with the cabling system, and each lamp has to sort of be networked to the others. And so part of the challenge was that, creating almost a canopy over the exhibition. And these are some images. What we really were interested in as well is creating this stayed in a space for several months, creating a space where students, faculty, staff could go in and sit on these. I mean, sometimes I saw people sitting in there having their lunch. It was like a kind of, again, an idea of a garden of how you could turn a space into the school into a more kind of socially activated space for a short period of time. And then the drawing is present, just reflecting again, like I started out talking about the Marcel Duchamp piece with the strings and the rulers. Here again, it was kind of like reflecting how the geometry is very precise, but then when we translate it into things and we pour materials in and we cast things or we blow glass into those forms, the kind of precision of the geometry gives way a bit to the material agencies. And so we really wanted to allow, like, what can the material produce when it interacts with this kind of precise form. This is another one of our projects called Semblances, where we were looking at the relationship between images and objects. And so we began by photographing rocks and stones, and then using a kind of, in Photoshop, beginning to transform the images through contrast and use that as a kind of template to extrude, and then going back into Rhino and producing the 3D object as an extrusion of these images. And so the question was, did the image produce the object or the object produce the image? This was developed with the support of the COLA program, the City of Los Angeles, in the Los Angeles Municipal Art Gallery. Every year, they sponsor a series of fellows for an exhibition there. And so we were very fortunate to be among 12 other artists in this exhibition, and to have the support to develop that work and exhibit it there in the Municipal Art Gallery next to the Hollyhock House by Frank Lloyd Wright. And this last project is called Environmental. This is a collaboration between a colleague of mine, Herwig Baumgartner, who is also faculty at SciArc and has an office in Los Angeles, and Hernan Diaz Alonso, who is our director of the school at SciArc, invited us as faculty to curate and co-design an exhibition having to do with some aspect of the environment. And this was taking place around the time that the 6th Street Bridge was being kind of dismantled for the new bridge to be constructed. And so this is 2018, the summer of 2018. And there had been like a lot of the, as the old bridge was taken down, a lot of the remnants and the sort of rubble of the bridge were kind of present on that site. And it got us thinking, you know, how could we take things like that, things that are normally hauled off of a construction site and become a landfill. We were like, what if we actually borrow some of that material, bring it into the gallery, and really reflect on, you know, that the built environment never just goes away. Like when we build things, when we design them and construct them, they are with us really forever in some form, even in this form. And we were like, how can we take some of that material that's no longer maybe useful in terms of its building life cycle, but make another sort of landscape out of it? And then in the foreground, this piece is designed by Gilles Retzin, and he was looking at modular techniques of construction, like how you could make a system of joints based on traditional Japanese joinery, but using digital technology. So he built this model to get us thinking about like new kinds of tectonics, using pieces that are identical. And then in the basin that's hovering over, that is actually from La Brea tar pits at the LACMA campus. I don't know if any of you have been there, but the La Brea tar pits are actually an active archaeological site. And it's where really the asphalt is kind of sort of bubbling from beneath the surface of the earth. And so we thought, let's bring some of that. So we borrowed as well. They were very interested in the exhibition. We went and visited the archaeologists, and they allowed us to borrow some of the asphalt to bring it and show like this is normally under the surface of the earth in Los Angeles and in many places of the world, but we don't think about it. But we wanted to like make that visible. In the other basin is the kind of vegetation that grows in the Owens Valley, where we source a lot of our water in Los Angeles from the Owens Valley. And the Owens Valley used to be a very rich agricultural area. And because the water was channeled through the aqueduct to make Los Angeles into a city and sort of bring water here, that landscape changed and became a very dusty, dry, arid landscape. And so the vegetation you see is the vegetation that thrives there. We did this project in collaboration with Günter Vogt's office. Günter Vogt is a landscape architect from Switzerland, from Zurich. And then we invited several architects to show work that was engaging aspects of the environment. And we had everything projected into these, everything in the show was sort of upcycled from materials that were no longer being used for their original intention. So these steel basins were actually the cap for water cisterns, for like water storage tanks. And so we opened them up, we inverted them, we filled them with water, and then we projected the media into the basins from the various participants, like Izaskin Chinchilla and Carme Pinos were part of the exhibition as well. And you can see here how the things are changing throughout the duration of the exhibition. The pink light is from the growing light that allows the vegetation to thrive. And then these are just some examples, some views of this kind of rocky landscape that we created in the SciArt gallery. So again, we were interested in creating an environment rather than creating a like an object or materials on the wall to look at. We wanted to really create a space that was like, again, a sort of garden within the school. And I think that that is my last slide of our work. I also, if you'd like to have information about the school, I also have some slides I could show about that, but or we could open up to questions.
I think we definitely have time. We can see if anyone has questions now.
Okay.
Because we don't have any in the chat. But if we're still waiting on questions, I'd love to see more of your work.
Okay. Oh,
Does anyone have any questions on Marcelyn's presentation? You can ask in the chat, or you could also raise your hand. Going twice. All right, I guess for now we can take a look at
okay,
your
I'll
extended.
show. Oh yeah, this was just some information about SciArc for those of you who might be curious about our program, the SciArc undergraduate program. There's a question. Hi, Brian.
Hello, everybody. Most of you know who I am. Wonderful presentation. Thank you. I love the process description and how you went about it. I recognize right away the CNC work and the way you guys are working with the model. I've been a wood chopper for decades, so I kind of got the idea of how you were going about that process. That was awesome to see. But I think my question came about is when you guys are making those tiles, those roof tile things. Could you do one talk? I mean, because I know the materials that you used would have a tendency to be rather heavy.
Mm-hmm.
So I know that was probably a process you guys had to mitigate during the process itself, was, being able to move them effectively without, one, damaging them, and two, keeping their appearance. I like the idea of what they were supposed to do, though. The concept was really, really unique, and I like that part of it. And there was something else. What was it? And the last one, the environmental one that had the large room, that was kind of speaking to the aridness of the California and the way you guys are bringing those materials in from the 6th Street Bridge. What was the material that made the architectural pieces, the black constructs? What was the material that was used for that?
That was actually chipboard.
Oh.
That was. Yeah, because the Gilles Retson, who was one of the exhibitors, he is based in London. So it was an interesting process because he wanted to be able to work like remotely. So he sent digital files, and the SciArc students who enrolled for the workshop, they were translating, laser cutting the digital files in cardstock and in chipboard. There are different thicknesses, like the black one was a cardstock and then the gray pieces were chipboard. And it was a really wonderful way, instead of like, he said it's ridiculous to travel or ship this stuff from London. So I can send the digital files, we can make it there. So it was kind of also for him, the first time he saw it was when he came to come to the exhibition and participate. And so it's a series of interlocking pieces, quite lightweight. In his own work, he's exploring that with glue laminated wood with like CLT, cross-laminated timber constructions. But it's true what you pointed out, I think, about the weight. That was something we really struggled with the roof tiles, is like, how could you, for the exhibition, it was fine because they were sitting on a floor and they were even supporting the weight of, we use them almost like things you could sit on or lean against. But then the thought was, if these would become part of a roof system, how could we reduce that weight? That's, I think, a challenge. Also, we learned a lot about the slip casting process. I mean, I had done it when I was younger. I had a small kiln and did like small casts, slip casting, but you have to be very careful because when the wall thickness of your piece gets too thin, and the clay is always shrinking somewhat, depending on what kind of clay, they always have a different percentage of shrinking. So in that case, we did have some experiments where it cracked because that we tried to make it too thin. So that's exactly the area that we need to continue researching, that you pointed out. So thank you for that observation. Yeah.
Just another, I was asking what's next. It'd be interesting if there was a way to keep the natural material, but also be able to infuse the newer technology that would allow you to be able to gather sunlight and solar energy within each one, kind of like a hybrid process, making it lighter, but also yet making it double effective, because the way the water collects and you're looking to have small plant growth in there. It'd be interesting if there was a way to put some sort of solar collectivity involved with that as well. and maybe being able to capitalize on hollowing out the inside a little bit. So just the thought process, maybe I'm that kind of guy, but I really liked your presentation. Thank you very much.
Thank you. Thank you so much.
Thanks, Brian. We have a couple questions in the chat, Marcelyn, if you don't mind. So one of them, Jesse, do you want to ask your own question, or are you here? Can you unmute? No, Mike. All right. So, I mean, I'm going to have to elaborate on it. I'm not sure if he's being very specific, but he says, have you worked on any buildings? I think he's maybe meaning any more specific buildings, like around local, something along those lines.
Yeah, actually, our practice is a very small practice that is working primarily with the kinds of investigations that I showed today that are more kind of experimental processes, looking at materials and how form and materials come together in a series of interior objects. And sorry for, there's a little bit of sound in my background. I'm sorry. I'm at the school, so there's someone in another space. And I personally have worked for other architects during my training. I worked on a school in Berlin. I was living in Germany at the time. And I also worked on a train station, the roof of the train station. But my own professional work now is not at all at that scale. So I don't know if that answers your question, but.
He says, thank you. All right. Adam, do you want to speak up, or if not, I can read it. So Adam Martinez, who's one of our adjuncts at Elac, is asking, hey, Marcelyn, nice to see you again. Can you speak a little on the benefits of a SCI-Arc education over other schools in LA? Students are curious about the differences between education between the schools.
So I think the way I would characterize our school is that something our director calls architectural thinking is what's really unique here is we're a fully accredited STEM institution. So you can obtain your license. We are NAB accredited, WASC accredited. But in addition to that, we also open up the exploration into fields that extend what architecture can be. So some of our graduates do work in firms like Gensler or some other offices in Los Angeles and also nationally, some internationally. And other of our graduates work in adjacent fields. Some of them work with the film industry. Some of them go into game development. Because at SCI-Arc, what we do is we use tools that are not always thought to be designed specifically for architecture. So in some of our studios, in addition to learning things like Rhino or Revit, you can learn things like Unreal Engine, certain softwares that might be designed for gaming simulation. But then we look at, okay, as architects, how can we show the interior of the building using the simulation software? So there's a very exciting project in the second year where the students are working on a library and data center. And I just went to their reviews about a month ago when we finished up our semester. And they made these beautiful simulations where you could see in real time what the interior of the library would look like and how the data center might be interfacing with that and different light levels. So that is kind of something quite unique. We also look at different kinds of fabrication technologies. We have a robotics lab where we're doing currently, some of our faculty and students and researchers are looking at a CLT construction, cross-laminated timber. And specifically in that project, we are using wood that has been deemed not structurally sound on its own. And then we're routing out the parts that are damaged and starting to laminate in new pieces. So those are some of the kind of projects that are going on at SCI-Arc.
Great. Does anyone else have any other questions? Adam says thank you.
I just want to compliment and thank you for the exposure to your projects. I think that the organic approach is really beautiful, and how you interconnected nature with structural systems. I think that's really amazing and that's exciting, and gives optimism to the future of where architecture is heading. So thank you.
Thank you so much, Adam. That's really nice to hear your thoughts. And I've enjoyed presenting the work. Every time I present the work, I love these sessions with Q&A because I learn so much as well, and from all your suggestions and thoughts on the work.
We have another question that's in the chat in our Q&A section. I don't want to pronounce his name incorrectly. The one who asked the question in the chat, do you want to speak it? Or if not, I mean, they're two different questions. So I could read one of them first. So they're asking, how do you decide which design process to approach for a project? For example, the shard wood one. And I think you said something about worms and stone for the other project. I think they're asking sort of along the lines of like inspiration and things like that.
Yeah, that definitely comes from looking at architectural history, but also thinking about different traditions. Like with the charring of the wood, we became very inspired by looking at the Japanese techniques and some buildings that incorporate that wood charring as a way of sealing the wood. And it sounded like something that could be understood in a contemporary way as well. So we like to think maybe that we can learn both from all of our current technologies, but also looking at like things that were done many years ago. And I think there's so much territory there to be explored. I think not something we've looked into yet, but earth construction, I think, is extremely exciting to consider, like rammed earth. And David Ajay, the architect, has done a project called Asase, which is a word from a Ghanaian word. He's from Ghana, for the project he designed that is working with like rammed earth construction. And he started showing that also in the context of a gallery, because some of these things one has to experiment with. And so that's why a lot of times it's like the gallery allows, like, it doesn't have to fully be resolved yet. We need to like understand its structural capacities or its capacities for insulation. So the inspirations are kind of looking around at other works of architecture, but also at material techniques around us.
Terrific. That sounds great. We have someone in the chat shouted out rammed earth, Brian, again.
Oh, yeah.
It's a fan. So I don't know if you have time for any more questions or if you wanted to get into quickly to your undergraduate program.
Okay, yeah, I can, maybe I'll just, let's see if I'm, okay, so this is the undergraduate program. This is just a presentation that our admissions office shows, thinking about, you know, different forms of architecture, how architecture can take on these forms that maybe are more familiar, of things we see existing in the city. And this is something I think also at SCI-Arc that we consider is also like what architecture can be. On the right is a design by one of our faculty that was here teaching a few years ago, Alexis Rojas. He did for Coachella and constructed this project at Coachella. And on the left is a project by our director, Hernan Diaz-Alonso, looking again at different qualities, like how can we imagine all the way that, you know, architecture can look, what can it do, how can it perform. Some of you may be familiar with this building in downtown Los Angeles by Frank Gehry, Disney Concert Hall. Again, showing a different formal logic and how that can be realized in the context of a building. I wanted to show some images of our thesis reviews. These are the kind of events that I was mentioning it at the beginning of the call when we were just chatting before the lecture, that are building every year at the end of the spring semester and the end of the summer semester becomes filled with all the ideas from the graduating class. So each student presents their work to a lot of guests, and faculty. This is just the exterior. I mean, you can see our building behind me in the, it's daytime here as well. I'm also in downtown Los Angeles, but it's a night view of our building. And that's the exterior. So this is the interior showing some of the studios. Every student at SciArc gets their own desk and workspace. And those workspaces, you know, sometimes people bring computers in, sometimes physical models. Probably looks familiar in some of your studio working environments. These are the kind of desk crit situations, looking at redlining of drawings and faculty and students discussing together and looking at the work. Our school's quite small, it's 500 students total. That's for the undergraduate, the graduate programs, and the postgraduate program. So everybody really gets to know each other. Like as faculty, we all know each other. I know pretty much every student. And as I said, we have these kind of long, because it was a freight depot for a long time. The building is designed as a, you know, kind of linear quarter-mile long structure. And that really is wonderful because we can have our pinups and reviews. We have a mezzanine where students can actually see all the work that's going on in the school. These are more images from thesis reviews. These are some of our faculty and their work. And really almost all the faculty that are teaching here, aside from history theory faculty or liberal arts faculty, all the architecture faculty have their own practices. And this is just sort of listing some of the features, the hands-on based studio program. And to the right is an image from 2 students who did a collaborative thesis. And that was presented just before the pandemic, that project. And you do receive a professional degree, NAB accredited degree, a Bachelor of Architecture, design excellence, technical expertise. We really focus on liberal arts and kind of critical thinking and learning about not only the architecture, the field of architecture, but also in the first couple of years, we have classes that focus on writing, race in America, film, philosophy, literature. So really kind of having a, you know, a look at adjacent fields that we as architects engage with. And as I mentioned, practicing architects as instructors. These are some images of different projects that come out in the, on the left here, we see some of, when I mentioned the Unreal, the gaming engine, in the first year, the project culminates with a simulation that students produce. So they're working with physical objects, like everyday objects that they bring in, and then they're making digital models that are kind of using what we call assets in the game engine software, and then creating these kind of scenes. And then you can see other projects that are buildings dealing with the context, in this case of Chinatown in Los Angeles, and then other projects as you progress through the curriculum that become increasingly more complex. These are some, excuse me, some of the third year projects, and we can see the plans and the idea about cellularity and how one could accommodate a multi-unit housing complex. This is a project from the fourth year. And this project was from the second year for a cluster of classrooms, looking at how a school campus might be rethought as like a distributed arrangement rather than everything being in one central space. And then also the technical aspects. We have a very thorough curriculum with design development and construction documents and advanced project delivery and professional practice. All those courses are taught. These are some of the thesis projects from the undergrad thesis from the core. And just, you know, moving from the ideas of speculative design to how do we realize that? What is the structural system like? What are the tectonics? What kind of material specifications? So all of those aspects are covered. And then in your vertical studios, after the core curriculum, the final year and a half of the program, you, excuse me, you select your studio. So all the faculty present what they're going to be working on in that studio, and then you have a choice. So you can work with a faculty member who is doing the kinds of work that you want to explore. And so some of those studios become more speculative. I think this one was the studio of Eric Owen Moss. Some of those studios are really focusing on building design, and others go a little bit more into the cinematic areas. The liberal arts curriculum, just showing some of our classrooms. On the left, you see, since the remote period of instruction, we've equipped all our classrooms with a Zoom. It's kind of called a Zoom room, because anybody in the room, you can use your phone or your laptop or your iPad or whatever your device, you can project into that screen without even entering the Zoom call, because it's all you need is like a code that is coming from the screen. So it's a really great way. I use it all the time in seminars. We can bounce around and somebody in the class can show something, and then we can go to another student. And these are some of the public programs with Slavoj Žižek, philosopher, and the costume designer from Black Panther, Ruth Carter, who came in to speak in lecture series. So we have evening lectures that are open to the public as well. And then thesis, these are thesis presentations. Some of you might know Barbara Bester. She's sitting here. She's a SciArc alum who has an office here in Los Angeles. And she comes to many of our reviews. These are just kind of, again, showing students presenting their ideas about their works of architecture. In this case, these two students had looked at a museum in Madrid, the Prado Museum, and had proposed doing a kind of extension to that museum. More situations where students are presenting their work and getting feedback on that. So it's a very dynamic environment. I mean, if you are around in September, I believe it's September 9th or 10th, this will be happening for the graduate students, but it's a great time to come in and just see and kind of listen to some of the conversations and hear what the students are talking about, what's on their minds, and learn some things from the faculty as well. And of course, our location is 3rd and Santa Fe. So we're in the Arts District, excuse me, which many of you may be familiar with. We're actually not so far away from your school, quite close. And on the right, you see our graduation. We always have our graduation outside. The graduation pavilion was designed by Patterns, Marcelo Spina and Georgina Holyitz. And on the left, you can see we're right next to One Santa Fe, where a lot of students who aren't from Los Angeles choose to live because it's very close to the school. So we were fortunate when there are many residential units that have been built around the school in recent years. And these are some of the recreational spaces like resident and some of the bars and cafes. Our facilities, as I mentioned, we have shop facilities that have metalworking, woodworking, CNC, we have 3D printers, and we also have, this is the kind of open shop area that all students have access to. You get a training when you arrive at SciArc, and the staff are extremely helpful in guiding you through different workflows. This is our robotics lab, where some simulations can be done with using a combination. In this case, there's like a robot setup where there are 6 robots that collaborate with each other. So you can attach a camera to one and another end of arm tool to another robot and have one of them filming the workflow from a moving point of view. We also have a very large robot that is the one that I was mentioning, that is the cross-laminated timber project. That is a new facility we opened, I think it was a year and a half ago. On the left, you can see some students who have worked with clay deposition. So again, a ceramic deposition. So 3D printing ceramics and then firing, almost like slip casting, but a different method of depositing. And then just some of our other shop facilities with the CNC and 3D printers. And a lot of the seminars, like if you're interested in learning about these technologies, you can take an applied studies seminar, which is a 3-credit class. And some of those do a deep dive into those materials and technologies. And then we have opportunities for study abroad and collaborative workshops. Mexico City is one that's currently active this summer. We also have SCI-Arc Bogota, China, and Mumbai. And images of student life, like the studios are open 24/7, securely open. We have our security staff always on duty, but you can access your space at any time. And since the remote period, students work differently in those spaces. Like sometimes they will have their computer in there working, or sometimes they have a computer at home and they're networked to it and they bring in a small tablet. So depending on how you work, those are different ways of working. But we really do love the studio culture, because I always say to students and applicants, I think you learn the most from your fellow students. That really, the faculty are there, we're sharing our insights and our experience and expertise, but also like when you're in the middle of, working on a project and you're sitting with your friends in studio and talking about it and looking at what they're doing, you can really grow that way. You really develop like a collaborative spirit of exchange. And sometimes you're working with a technique where you might have a question and the person sitting next to you is like, I know exactly how to answer that. And so what is SCI-Arc looking for in an applicant? I always say dedication, imagination, curiosity, ideas about, what can architecture do in the world? Like thinking, how do we want to change the world, and what role can architecture have? And then these are some more images from our spring show. And applying to SCI-Arc, we use the Common application. And there is, in addition to the Common App questions, there's one question, why are you interested in architecture? And why are you interested in SCI-Arc? And we really enjoy hearing your thoughts on that. What might make this a good place for you? And as I said, we're always open for visits. So if you want to come by, I am happy to meet with you and show you the campus and introduce you to some of our admissions staff who can walk you through the admissions process. Test scores are optional. High school transcripts, we require 1 letter of recommendation, and then a portfolio of creative work is highly recommended. It's not required, but that would be showing your projects from school now. And, just having maybe little text describing what the project is. And the application deadline is January 15th. The transfer application deadline is later than that. That is in March. I believe it's March 15th. I could get the exact date from our admissions office. Then we also have programs in the summer. Design Immersion Days is for high school students, excuse me, to learn about architecture. And there are scholarships for this, and they come to the campus, and it's a 3-week program where they work on different scales. In this case, they were looking at the Los Angeles River and developing projects, imagining the future of the Los Angeles River. They also go on visits to offices, to architecture firms, and looking at iconic sites within Los Angeles and museums, design studios. So that's a really wonderful program. And you can see here some of the work that students have done in that 3-week summer program. And really the space of the school then is kind of given over to that group, that main space that we're looking at, which is normally our lecture hall. So if you have any questions about this, I'm happy to answer. And you can see our admissions at sciarc.edu and their phone number. If you have questions about the application process, they're always happy to walk you through that. Oh, I see a question, I think. Let's see. Hi, Jasper?
Yes, thank you, Marcelyn. I appreciate the introduction. I'm actually really excited for this opportunity. I was just accepted to SCI-Arc second year.
Oh, fantastic.
I'm currently in discussion with Justin and the financial aid department with organizing that. I was curious if there were any other scholarships or grant opportunities other than the ones offered through SciArc. I did get the admissions scholarship. However, other than that, there were no other scholarships. And so I was curious if there was any other resources.
Do you know if you've contacted or been in contact with Maricela de la Torre?
Yes, actually.
Maricela?
Yes, actually.
Yeah, because she has all the information on scholarships.
Okay.
Yeah, that, and she can also review like what your package is and be like, she has all the specifics on what you might be able to get in addition to that. We do have work study positions at the school. A lot of our students also work in the library or the shop or the media department. So that is also another way to help to finance your education. I know when I went to school, I did a work study program, and it was very helpful because I was also able to be on campus. So it wasn't like, I'm working across town and then having to come in. But yes, definitely maybe follow up. I will put, where did my chat window go? I'll put my email in here. And if you want to also email me, I can follow up and ask Maricela as well. Okay, let's see. Sorry, I'm just writing it in. SciArc.edu.
Thank you.
So, and this goes for anyone on the call if you want to reach out or if you want to tour, happy to do that. And is there another question, Brian?
Again, here I am. I'm very inquisitive. So I teach design to high school technical theater students. I teach design with them, and they basically design the sets for the season. We've had a couple of award-winning shows, but what I would like to do is I'm excited by this day, the summer days thing you guys have at the campus. And I'd like to know a lot more because I have a couple of students that are just prime candidates for this kind of event.
Oh, great. If you follow up, if you email me, and I can connect you with the admissions office, and they have all the information about it, like how to apply. I think it's on our website too. It should be right there on our website.
And is there a cost involved, or how does that work?
I think there are scholarships. There is a cost, but I think many of the students are on scholarships. I think they have financial needs scholarships. So
Excellent.
in those cases, I think it can also be no cost if you receive a scholarship. So that would be a great opportunity, I think, for them.
Excellent. I'll
Thank you.
I'll follow up. Thank you.
Okay, great. Thank you. Ariel?
Hi, I actually have a question going back to your portfolio work, if that's all right. So I think you said it was your 2013 exhibition, the one with the spherical and conical roof planners and the glass blown installation and the drawing. You showed us the final product of the planners as being altered by the materiality. And like digital experience is very precise, like it's super hyper precise. And so it's very deliberate to use a material that will change it in that way. Why did you choose the material that you did? It had some like porous altercations to it. And I know you said a lot of your work is investigating material affecting form, but why not do something that completely retains the digital hyper precision, or one that like more significantly deteriorates the perfection? Is there a threshold you define in that material process, or is there like a certain level of imprecision that you think humans need?
I actually, yes, I'm in some ways a fan of the idea that everything has like slight degrees of imperfection in it. And so even if that's what was fascinating to us about the casting process, is like if you have clay slip, which is like the liquid clay, depending upon how much water is in the mixture, you will get a different result from the ceramic, like its texture. And so we were really exploring, almost embracing that, like rather than trying to use the same recipe, we were sort of like, what happens if each time, there are different amounts of water, it's more chunky in one and it's like smoother in another? How can that respond to the same mold? So saying like the one mold giving different outcomes. But I agree with what you're saying, that it is one of the magic things about using the kind of precision of the digital technology and the CNCing of the form, is that you can get almost identical. Like if you think about a process of injection molding or something like that, where it's removing all the air bubbles and you can get a very, very smooth finish that will retain the intended form. But in that project, we were kind of interested in revealing like how material transforms the geometry.
Okay, cool. Thank you.
Thanks. Thank you.
Myra has a question.
Hi, Myra.
Yeah, thank you so much for coming out, and it's really exciting what you're doing, especially pretty much in the in what the last person was saying. You mentioned about how you like the way material has a role in shaping the form, and I thought about that because I thought that leads into what dealing with raw materials as well, and the idea of sustainability, and perhaps instead of trying to be using technology to be like perfectionist and go somewhere where we can go, but instead using raw materials to deal with the environment and see what they can do and how we can work with them, so we can work with the environment basically and think of sustainability. So with that, I had a question in where SciArc stands in environmental sustainability.
Yes, we are very dedicated to that and to looking at, and particularly in our applied studies sequence, the colleague I mentioned, Herwig Baumgartner, who collaborated with me on the exhibition, the environmental exhibition. He is teaching a whole course about how biological materials or biodegradable materials can be used for fabrication and things of that nature. Like how can we start to design knowing that certain parts will disintegrate over time, and build that into our ideas about the life cycle, rather than thinking of always using steel and concrete. What could these biopolymers allow us to construct, and where could they be applied? What's the current state of that technology, and where will it be in the future? That's one aspect. The other aspect with the CLT project, they were looking specifically at materials that would be discarded because they were considered substandard, sheets of wood, planks of wood that had things in them that had knots in them, or areas that aren't structural, and some of the wood reclaimed from burn areas, like when there has been a forest fire. So the research department obtained some of that would have otherwise been scrap, and they were like, you can work with this and experiment. And so currently that faculty and that research group are looking at how can we salvage pieces of the material and then connect it back together and make new structural members out of something that would have been a waste product. So yes, I think it's an area all schools are currently really engaging with and trying to figure out what can be the solutions for today, but also what can be the solutions for the future. Like how do we get better and better at that? Because I think architecture, we're just at a very, very beginning point of really being able to address that. I mean, we have, we understand how LEED certification is developed, but then there are also other forms of sustainability that affect our environment, like social sustainability. So a building can be made of very responsible materials, thinking about its environmental qualities, but then the question of like, where is the building located? Can people access it without driving there in a car? Like, could they access it with a bicycle, or could they walk to the building? And how is the building, who's constructing the building? What is the workforce that's constructing the building? Are there fair labor practices? So all those different degrees of sustainability are things that are being talked about in different classes in our curriculum, in the studios and A lot of the applied study seminars, even in history theory, I know some of our history theory faculty look to discussions of like historical practices and really starting to understand indigenous practices of construction and what we might learn from them. I know in one seminar, they've been looking at the Great Mosque in Djenné, which is in Mali, Africa, which is rammed earth structure. And every year, the residents of that town come together to replaster with the mud. It's like a community act of care and maintenance. And so that was a case study for one of the classes. And thinking like, how can we learn from those practices and think in a contemporary way? Like, how could we be informed by that rather than thinking that, you know, technological advancement is only the modern stuff. It's like, wow, a lot of the design intelligence is actually very, very ancient when you look to it. So
Thank you very much. I do agree with you that architecture alone is not going to solve the whole environmental problem. And so thank you. But I also did have a comment in regards to the tiles you were making, and I do like the idea of imperfections, you know, and dealing with these materials that biodegrade. There is a beauty to age, you know, to the patina that things can get, and how you can grow things out of them as well. So that was really great. Thank you.
thank you.
All right, thank you, everyone. Do we have any more questions? I think we're a little over, but thank you so much, Marcelyn. Thanks for joining us. I know it took a while to
Thank
get
you.
here, so thank you even more for even great rescheduling with us. It was great to finally have you here.
Thank you. Yeah, I'm sorry. I finally, I had not had COVID before, and that was
a little surprised.
that was the time. I still have this cough, you can hear.
Oh.
Yeah.
We didn't notice. But thank you so much for both of your presentations.
you.
The first one, it's gonna, I hope, inspire some of our students to think outside the box. And your SIREC presentation, hopefully some of our students are more interested to transfer there where they can do that. So thank
Great.
you.
Yeah. And as I said, you know, just please reach out. Happy to meet anyone who wants to. I'm here pretty much every day in the summer, this summer. So
Great. Thank you
great.
so
And
much.
good luck with all your final. When are your finals for this semester?
Next week, everyone, right?
Oh, wow.
Yeah, they got it
Good luck.
coming up.
And yeah, you have a long weekend maybe to prepare Memorial Day weekend. So